All right. Just look up. No need to look at your notes. Just look up. You know there are a few steps available. Is the sound cracking? Testing again? Can I don't need to talk too loud again? Can? Okay. Just look up. No need to look at your notes. Look up. See your faces. Your pretty and handsome faces. Come. Good. You know there are a few steps available to follow for hypo testing. Now we've done example 3. Let me just do a quick recap. Suppose you have a random variable x. X can be anything. It can be height, it can be weight, it can be delivery time, whatever. This is the entire population of x. Okay, population of x. And typically we are interested in the population mean. Correct? We are interested in finding out whether the population mean take on a certain value. But we don't know. What do? We take sample. Correct? These are the samples that we take. Okay, so we get 1, 2, 6, all the way to 26. These are the values. Correct? You want to make some judgment call on whether the population mean is 8. So step 1, what do? We say mu equals to 8. We want to check whether this one, whether is the 8. Correct? Follow so far? So we say, oh, okay, we do a two-tail test in this case. We say h1 mu not equals to 8. This is standard. Correct? We want to make use of the sample data to ascertain whether the population mean is indeed 8. Step 2, what do? Anyone? You look at your notes. Step 2, we say, oh sorry, actually this is step 2, sorry. Step 1 is define. Yeah. Let, already define. Okay, we say let mu be the mean of x, correct? That's what is in the notes, right? Let me be the mu be the mean of x. Then we define what is whether it's one-tail test, two-tail test. Step 3, we state the level of significance. Okay, a lot of us came forward and asked me, actually I'm very confused. What is level of significance? What is p-value? I can understand. I can totally understand. Let me put it this way. For now, you think about it. Level of significance, you think of it as your decision-making threshold. I repeat one more time, decision-making threshold. So this is decided before you perform your test. You are going to compare your p-value against this decision-making threshold 10%. I'll explain a bit more. Follow? 10% is decided up to the person who's conducting the test. Of course, in exams, the person deciding it is the examiner, the person setting the paper, you know what I'm saying? But actually, in real life, you decide what is your level of significance. Okay, enough said. Step 4, we look at a test statistic. And usually, we will write it as Z. See, if x follow, you want to determine whether mean of x is it 8. If mean is indeed 8, then x bar should follow a certain distribution, because typically in this case you are given this population variance. If you know population variance, if h0 is indeed true, then x bar should follow a certain distribution. Follow? Okay, because x follows a normal distribution, x bar should follow a normal distribution. If h0 is true, this should be 8, this should be 10 over 1, 2, 3, 4, 5, 6, 7, 8. 8. Correct? Then clearly z should be x bar minus 8 over square root 10 over 8. So far so good. Now, then what do we do next? Then we say, oh, okay, we in exam, in this case, if this question were to come out exam, this is exactly what I'm going to present. Then you say, I will compute p-value. Immediately I will compute p-value. Because I know since x bar from GC, actually no need, actually, this one is from GC. You key in your GC, correct? And you compute your p-value, you realize that your p-value in this case is 0.093523. This is the important thing that we need to understand what is it all about, which a lot of us are very confused. Follow? Okay, now I'm going to explain now what is this, exactly what is this p-value. It's very interesting now. P-value is this. Suppose the mean is 8. Okay, suppose the mean is 8. And you, after calculation, you found out that, you go and find out, actually the x bar calculate here is, actually is in the notes, 9.875. This is the observed value. This is the observed value of x bar. This is the observed value of x bar. You are going to base your decision on this observed value. The further it is away from the 8, the more evidence you have against it. Correct. One more time. The further that value, or the observed value, is away from 8, the more evidence you have against it. And because it's a two-tailed test, it can be this way, it can be that way. Follow what I'm saying? Because it's a two-tailed test, it can be this way or it can be that way. So now, what is this p-value? The p-value is the probability of obtaining a sample mean as extreme as 9.875, which is what you observe. Now, in a two-tailed test case, when we say as extreme, we include the two areas here. Two are both-sided. Okay? Two-sided. I know it can be a little bit confusing for some of us, because one-tailed test you can understand. When it comes to two-tailed, you get a bit confused. I can understand. For now, you accept it. Just follow first. When you perform more tests, you realize that it all makes sense. Follow what I'm saying? So, just now I mentioned, one more time, you think about it. The further this value away from the mean, the more evidence you have against H0. Against, correct? Similarly, the smaller this probability is, this p-value is, the more evidence you have against H0. Follow? So if you have a small value, then you say H0 not very good. Mu not equals to. So how small is small? Then we go back to this level of significance 10%. If your p-value is less than 10%, then you say H0, rejected. Follow what I'm saying? Yes, because it's a rare event, correct? Because it's a rare event. So you start off with saying mu is not 8. Since it's a rare event, then the original assumption of 8 is not correct. Therefore, you say H0 rejected at 10% level of significance. Follow? So, in this case, we calculate this p-value. This is the sum of these two areas. Okay, the sum of these two areas. Then we say, oh, okay. We conclude since p-value is 0.093523, or rather just like that, which is actually less than 0.1, which is the level of significance, then you say H0 rejected. Since we say this is small enough for this to be considered far away from the mean, H0 rejected. Then we say H0 rejected. Of course, the proper way, wording, you look at your notes, because we have gone through this example. Follow? Okay? as you go through more examples, you will realize they all make sense. Ken, is that all right? Is that all right? Good? Okay, good. Now we go to 4.2. Okay, next, I think it's page 13. Okay, 13. In all your questions so far, you have your population. This is your population. You want to test your mean, and most of the time, in your example, the population variance is known. Alright, you always, the question, can I have attention please, thank you. So far, we all said that the question always says we know the population variance. So what if the population variance is unknown? This is what we're going to discuss in 4 point. What if the population variance is unknown? Actually, very simple. If your sample size is large, what do we mean by sample size large? You collect a sample, right? To check, to test what is this one, right? If your n here, number of samples here, is large, then we can use our unbiased estimate. Remember our friend unbiased estimate from the last chapter? You can make use of the data here to estimate the population variance. And what do we use to estimate the population variance? We don't use sample variance. We use the unbiased estimate called S squared. Follow? The bigger the n here, the better the estimate is. Remember? Correct? So we're not scared. So now, look here. If it is unknown, correct, we can estimate sigma square using our friend unbiased estimate. That's all. Because n is large, it's a very good estimate. Follow? Then we're not scared, then we just follow the same thing. Follow? Follow? Now, if the population is given to be normally distributed, then it becomes very easy, right? Then population normally distributed, x bar should be normally distributed, and we, even though we do not know the sigma, by right this should be sigma square, should be population variance, we use S squared to estimate the population variance. Follow? So, and after that, the steps are all exactly the same. The only difference now is this thing called S squared, since we do not know the population variance. Okay? Your friend next to left and right, something wrong with you. You make your friend sleep. Left and right both sleeping. No, I'm just kidding. No mind. You make them sleep. Can okay, can. Early in the morning, don't sleep. Okay? Okay, can. What if population is not normally distributed? Look, one more time. All along, we have been doing this, you know. I don't know whether it makes sense to you. In example 1 to 3, we have all along said that x is normally distributed. Correct? X has all along been normally distributed. If x is normally distributed, we say x bar follow a normal distribution with mean mu sigma square over n if h naught is true lah. Correct? Yes? Follow? But now x bar means the mean of your sample mean. Now, what if we have a population, X bar, not normally distributed? What happens to, if X is not normally distributed, can we say X bar? Can we know the distribution X bar? We can only if n is large. Very good, use central limit theorem. So when we use central limit theorem, then again we come to the same conclusion. If it's not normally distributed, we can only conclude this using central limit theorem, provided n is large. Follow what I'm saying? But what if n is small? That's how I was to ask, correct? What if I have a population X not normally distributed, n is small? How to test? Not serious. Serious, not serious. Okay? Follow? N must be large. If X not normally distributed, n must be large. To use central limit theorem. But we notice here, I want to emphasize this. You see, in this case, there are two approximations, two levels of approximation. First level, not here. First level is here. If we do not know the population variance, we have to estimate it. That's approximation 1. Follow what I'm saying? If the question does not give us the population variance, we have to estimate it using S squared. That's 1. Second approximation is central limit theorem. Since the distribution of X is unknown, if n is large, you say X bar follow a normal distribution. That is an approximate distribution. So there are two levels here, okay? Can you be very clear on this? Can you be very clear that what are the two that we're talking about here? Can? Alright? Alright, can? Okay, let's do example better. Okay? Example. Why